So what we're looking at today is two different, albeit very similar methods of trying to quantify how similar or different two strings are. Now, this is quite important for search engine autocorrection systems, but really any application that requires some sort of fuzzy finding capabilities. And that's because if we can quantify how similar two strings are, then we can sort and rank them based on that similarity, allowing us to serve only the most appropriate results. So the first measure we'll look at for similarity is the Hamming distance. Before we get started though, one of the key assumptions we make with the Hamming distance is that the two strings we're comparing are of equal length. So let's get started with the two strings Hamming and Shaming. Now, what the Hamming distance is effectively the number of characters we have to change to go from one string to the next. So let's count those changes. In the case of Hamming and Shaming, we'll notice that the last four characters are actually identical, and so they can go unchanged. But at the front of the string, however, we need to convert this H into an S, which is one change. We need to convert that A into a H, which is another change. And finally, that M back into another H. So we've got a grand total of 3 changes, which means our Hamming distance is actually 3. Now, the Levenshtein distance between two strings is actually very similar to the Hamming distance. The key difference, however, is that we no longer have that constraint of only needing strings that are of the same size. And the reason for that is because under the Levenshtein distance, we're actually able to add and subtract characters. So let's take a look at what happens when you try to convert haven into a word like shaved. Well, the first change we'll make is probably add an S to the start of the string. That's one change. And secondly, we can actually remove this S and turn it into a D, which is a second change. And because we've made 2 changes to our string, our Levenshtein distance is 2.